All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our natural language module. Let's have a look at what we went over tonight. Now, we were supposed to run some code, but we ran into a hiccup, but I'll explain that when we get to the part. We're going to start with some light reading. So, what happens? So, what problems might we run into here? What could potentially go wrong when doing this kind of analysis in order to analyze what text is a positive or negative sentiment? Well, a couple of problems might arise. One problem might be, what if the word wife never appears for any of the positive reviews? If that were the case, then when we try to calculate the value, the probability that we think the review is positive, we're going to multiply all of these values together, and we're just going to get a zero for the positive case. Let me show you what we mean. So we said when we multiply this by this, if wife is a zero, that means it never showed up in any of the reviews. That means the entire field is going to be a zero because anything multiplied by zero is going to be a zero. So it's going to throw our whole calculation off. So that's what that means there. So that's because we're going to multiply by that zero value, like I just said. And so we're going to say that we think there is no chance that the review is positive because it contains the word wife. And if our training or in our training data, we've never seen the word wife appear in a positive sentiment message before. And that's the problem. And that's probably not the right analysis because in cases of rare words, it might be the case that in nowhere in our training data did we ever see the word wife appear in a message that has a positive sentiment. So what can we do to solve this problem? But one thing we'll often do is some kind of additive smoothing where we add some value alpha to each value in our distribution just to smooth out the data a little bit. This is additive smoothing, adding the value alpha to each value in our distribution to smooth the data. And the common form of this is Laplace smoothing. And Laplace smoothing is adding one to each value in our distribution, pretending we've seen each value one more time than we actually have. So if we've never seen the word wife for a positive review, we would pretend we've seen it once. That if we've seen it once, we pretend we've seen it twice, just to avoid the possibility that we might multiply it by zero, and as a result, get some results we don't want in our analysis. So if we use it a place in a situation like we've never seen the word wife here in our analysis, the place will have the wife there once at least because it's going to add one to whatever we see. So if we never seen it, it's going to be a one. If we have seen it, it's going to be a two because it's going to add one to whatever we saw or didn't see. So that's what the place can do for us. So yeah. That if you've seen it once, I saw it. So let's see what this looks like in practice. Let's try to do some naive bias classification in order to classify text as either positive or negative. First, we'll get our imports. These are imports NLTK, OS, and sys. Then we got our define main, and then we have about 75% of the code. But the problem was we didn't get the entire code this time again, like he's done before in the past. He kept the majority of the code to himself, and he ran it and didn't allow us to follow along. He just did it as a demonstration, so I wasn't able to replicate the code and run it alongside him. So I waited all that time basically for nothing, but it's all good because we got past it and we're still moving forward. And of course, I will keep you guys posted every step in the way of what comes next. It's the Python Poppy. You guys stay Gucci.